Hello and welcome to World Talks here on TVP World with me, Axiom. After nearly 50 years, a Polish astronaut is flying to space again. Sławosz Uznański-Wiśniewski is part of the Axiom 4 mission to the International Space Station, or ISS. What does this mean for the Polish space industry and its role in the international space ecosystem? Well, to explore this, we're joined by Professor Grzegorz Wrochna, he's Union of Polish Space Industry Companies. Professor, welcome and thank you for taking the time.
Thank you for the invitation.
It's a pleasure to have you, sir. So, exciting, very, very exciting. Lots of delays before Axiom 4 actually launched. But everything seems to have gone so far, has gone very well. Tell us what we expect to have, in very general terms, what we expect to happen now.
Well, indeed, there were delays, just indicating that the space indeed is hard, and it still is hard. But the launch went quite smoothly, and we have just heard that the astronauts named the spaceship Grace. Partially because the launch was really graceful.
Okay.
Another reason was that for them the grace means also an elegance, and it means a harmony between the astronauts representing 4 different countries. 3 of them they returned to space after long absence. For the 3 countries, India, Hungary, and Poland, those are second astronauts. And especially for Poland. Poland is in space for almost half a century. Our first astronauts, called cosmonaut today, Mirosław Hermaszewski, was in orbit in 1978 already. But the modern era of Poland in space began in 2012, when Poland joined European Space Agency. And at the same time, the first 2 Polish satellites were launched into orbit. During those years, many companies emerged in Poland. Now we have counted more than 500 companies, employing about 15,000 people.
Okay, so sorry to interrupt you, because this I think, a really interesting point. So it's 2012 it started, so 13 years ago.
Right.
The whole space industry in Poland started to evolve and develop. And I think many people would be surprised to hear that. Tell us what aspects of the industry have developed and are quite advanced in Poland.
Well, Poland is a relatively big country, and therefore the companies and the research institutes, universities, they cover all the technologies which are used in space. But those are mainly small and medium-sized companies. It is a drawback, but it is an advantage on the other side, because that means that they are very flexible, they are very innovative. They produce apparatus which flown to space on almost 100 missions to orbit, but also to different planets of the solar system. But this mission is a real breakthrough. It's a breakthrough first because we have a second astronaut. But what is even more important, the astronaut is going to conduct 13 experiments proposed and prepared by Polish companies, Polish scientists. When together with European Space Agency we launched a call for proposals for experiments, we achieved 66 quite mature proposals. We were surprised that the Polish space sector is so well prepared to make research, to make study in space, but only limited space, limited time of the astronaut allows us only to select 13.
Give us an example, what kind of studies?
The spectrum is quite wide, ranging from electronics, from basic research through biotechnology up to medical research. Medical research are of course important for the long-term missions. If we think of flying to Mars, we need to invent a way to produce food and to get rid of debris. And therefore, 2 of the experiments are dealing with some microorganisms, microalgae, and other microorganisms which could be used in future space missions. On the other hand, we have interesting example of a processor, electronics, core of the computer, which is especially designed to work in a space environment when the radiation is really hard, and therefore it is very difficult to design electronics which withstands those harsh conditions. And thanks to this kind of processor, we can process images taken by satellites in orbit, directly in orbit before sending them to the Earth, which allows us to take many more images at a time.
Right.
And other practical applications are for missions to Moon, to Mars, for self-sufficient operation of rovers, of spacecraft. So very interesting applications indeed.
How are all these things powered? I mean, of course, most people think about, plugging something in to the electricity socket, but there you are in space. There are no sockets up there. How are they powered?
Well, in fact, they are sockets, but the sockets are powered by huge solar panels, and the solar panels, they have a size over 100 meters times 78 meters or so, which is the size of about a soccer field, a football field. Yeah.
Okay, so they are powered.
So it is really huge.
So tell us now, zooming out a little bit, about how the Polish space sector has actually integrated or is integrating into the bigger European picture. Well, when we think about space, of course, the first country that comes to mind is the United States. They've always, been seen as the leader, but Europe's not far behind, I get the impression.
Well, indeed, and Europe is participating in many international programs together with other agencies like NASA or Japanese agency JAXA. When we are talking about for example, Artemis program, return to the moon, but we are talking about the permanent return and building a permanent bases on the moon. Then European Space Agency is responsible for building a special unit attached to the unit for the crew, which provides all necessary means for the crew. I mean, the fresh air, the power, and so on and so forth. So in every big international mission, ESA has its own part, and ESA is also launching many very ambitious projects for studying far objects in the solar system. A recent example is the mission JUICE, going to Jupiter and Jupiter moons, when out of 10 scientific instruments on board, Polish companies and institutes participated in 3 of them. So we are there indeed.
So truly international effort, and you're saying not just European, but also US, Japan, and so on. Also.
That is true, but the European Space Agency is an excellent vehicle to develop space technologies in the member countries. Every 3 years, ministers representing the member states, they meet in Paris and they decide on the program of ESA for next years, voting just by putting money into different projects proposed by the director of ESA. And those projects will be conducted when collect enough money. And the money invested by the country is then brought back to the companies, to the research institutes from this country. There is a geo-return rule guarantee.
So Japan might invest, 10 million euros or whatever, and then that money would be sent to the research institutes for that project.
Except that Japan is not a part of European Space Agency, but cooperating with it on many projects. But for European countries, it is true indeed.
Okay, understood. Now, what's the overall goal? I mean, are we seeing, a situation where the moon is being inhabited and, travel between the Earth and the moon was no longer a matter of space fiction, but a matter of space fact? Is that what we're talking about?
Moon is a very interesting object. I mean, more we know about the moon, more question marks we see. Also, the moon is an important milestone for going to Mars. I mean, on the moon we can learn how to build permanent bases, and from the orbit of the moon could be easier to launch a long flight to the Mars than from the orbit of the Earth.
What's so special about Mars? Why Mars, not Pluto or Venus? Or
it is. Mars is just closer, and the environment is much more friendly, if we can say friendly environment for Mars, than the one on Venus. On Venus, it is very hard for the apparatus to survive, not mention even people. Whereas the Mars is quite friendly in the sense that the rovers and recently even helicopters can work there pretty safely and for pretty long time.
So now our imagination's going a bit haywire here. So can you imagine? I mean, can we imagine a holiday in Mars, for example?
Well, why not?
Why not?
Already today we have space tourists. Okay, if you pay enough millions of dollars, you can fly to orbit today.
Right.
Why not to Mars tomorrow? I mean, tomorrow means 30 years maybe,
Right.
but sooner or later it will happen. I would not expect permanent colonies on Mars. Because we do not have permanent colonies, for example, in Arctic regions or on the bottom of the ocean, right? But permanent scientific bases, yes, we have on the Earth in those harsh areas, and I believe we will have them quite soon, in a decade or two on the Moon, and 3 decades perhaps on Mars. But we are talking about scientific research, we are talking about exploration. But today, the center of gravity of the space sector really moved to practical use. I mean, the satellites in orbit is really an infrastructure as necessary for our everyday life, like, highways, fibers, or airports. The satellites provides navigation we use every day. That provides precise timing for distributed system, energy system, for railways, but also telecommunication. I mean, every TV program, even this one, goes somewhere through satellite, right?
Goes out to a satellite first.
But most of the applications comes from the Earth observation, and the biggest application in Poland, for example, and in Europe in general, is agriculture. Because now all the actions on the field are planned thanks to satellite images, and then we haven't mentioned yet security and
defense.
and defense, right?
Unfortunately, we're going to have to end it here. You're going to have to come back and tell us more about those areas soon, I hope. Thank you very much indeed for throwing some light on the topic for our audience.
My pleasure. Thank you.
And that brings us to the end of this episode of World Talks. Don't go away though, lots more coming up. Goodbye.